All right, so I did this whole video and I failed to click the button or the icon. Yeah, the icon, because it's not a button. Where it says that I needed to tell the system to record my voice. So here we are. Attempt 2. All right, so this example says for the quadratic function f of x squared plus 8x plus 16. Answer parts A through F. So part A, they would like for me to find the vertex, the axis of symmetry, and determine whether the function is concave up or concave down. So when we're given a function and we need to find the vertex, we have our beautiful formula over here. That gives me the x bar of the vertex first. Okay, so the function I have is f of x squared plus 8x plus 16. So this is my A, B, and C. So I am just going to go ahead and substitute my values. So x equals negative 8 over 2 times 1. Negative A over 2 gives me negative 4. This is the x part, the x component of my vertex. Right now I need to find the y. So that is by me substituting the value of x into the given function. So when x is negative 4, what is the y? So I have negative 16 minus 32 plus 16. Negative 16 plus 16 equals to 0. My vertex is a point, so negative 4, comma, 0. This is your HK, if you remember, for when it's in vertex form. Now let's check if we did that right. So I'm going to type in negative 4, comma, 0, close parentheses. Check my answer. Oh, yay. All right, so now the axis of symmetry. Remember, the axis of symmetry, it is a vertical line that crosses, that splits the parabola in, oh, that's not a vertical line. That doesn't look like a very good line. That splits the parabola, okay. Okay, you guys know I cannot make straight lines, but that's a vertical line right there. So the vertex is the x, your h part of the vertex. So it's a vertical line. Your axis of symmetry, my bad, is the x component of your vertex. And it's an equation, and you want to make sure you type in an equation, because if you don't, it will mark it as wrong. Now, if it's concave up or concave down, this is based on the coefficient of the A. The A has a positive 1 right here, which is positive. So this is positive. So this is concave up. Smile. So let's pick that and see what happens. Okay, fantastic. So now I would like for us to find the, let me get out of draw. No, home. Oh, caramba. I need to scroll down. Okay. So I need to find the x-intercept now. So I am going to set my function. What color do we like? I don't know why I'm changing the color so much. So my function is f of x equals x squared plus 8x plus, I'm trying to go a little bit faster because the video that didn't work, it was like 14 minutes, and well, that's like a lot. So if I'm looking for the x-intercept, I am going to set y, which is f of x, to 0. I am left with this quadratic, this trinomial, and questions to ask is if it's factorable. If it is factorable, then go ahead and try to factor it. If it's not factorable, then go ahead and try to use the quadratic formula. But this one is factorable. So factors of 16 that add to a and multiply to 16. Now this is set equal to 0, so I have to set each binomial equal to 0 and solve for x. Okay, notice how I'm going to get negative 4 for both. It is the same. So they want it as just the value, so they don't want it as a coordinate point. So we're just going to type in -4. We don't need to put both because they're the same number. And the next question, I would like for us to find the y-intercept. So let's go ahead and do that. So to find the y-intercept, I am going to set x equal to 0. Okay. And I am going to simplify. All of this goes away. So f of x equals 16. So my y-intercept is 16. Boom. Check. Yay. Now it would like for me to graph it using everything I know. So far, let's get this highlighter if it works. I know my x-intercept. I know my y-intercept. And I also need to know my vertex. My vertex is the point -4, 0. So I'm going to go ahead and graph this knowing those three information. And I also know that it's going to look up because it's concave up. So you start by graphing the vertex, which is at the point 0, -4. And then let's put the y-intercept right here. 0, -16. With these 2 points, we should be okay. But if anything, you can always double check, like, what is x what is the y when x is -5? You can always substitute that in here let's say you pick -5 for x. So you substitute -5 here into the function, and that will give you what is the y value. So you can have another point if you wish. But let's check that. Hopefully I picked -4 correctly. Okay, yay. Now, the domain of a parabola, notice at the end, these arrows are going to -infinity to +infinity. So the domain for this parabola is all real numbers. So in interval notation, we go from -infinity to +infinity. Parentheses on both sides because we don't know when it stops. Okay. Now, for the range, let's keep in mind this referring to the y values, okay? So we start touching the y's when at 0 right here. So below, there's nothing in the negative size. So the range goes from 0 to +. Wait a minute. Now at 0, we need a bracket because that is part of the solution set. Okay? Because 0 is on that point. That point is right there. Okay? Now the next question is asking, maybe I'm rushing too fast. No, let's see. The next question is, the function is increasing on what interval? So when we're talking about increasing or decreasing, we are referring to the x values, okay? So let's think about this. Okay, there. Click. So from -4 all the way to -infinity, the x's are decreasing. From -4 all the way to +infinity, the x's are increasing. So from -4 to +infinity, my x's are increasing, okay? Versus from -infinity to -4, my x's are decreasing, okay? Last question. Determine where f of x, so where are the y's greater than 0 and where are the y's less than 0, all right? Now, if you take a look at your parabola that you have right here in your graph, do you see anything where the y's are negative? Like this blue parabola here, this graph, does it come to the negatives for the y? No, it does not. So we can definitely eliminate B and C because it's not negative in any of those sections, all right? So we're going to pick A. Now we need to know, what are we going to put here? Where are the y's greater than 0? So in what intervals for the x's, are the y's greater than 0? Well, the y's are greater than 0 from negative infinity, comma, oh, this guy over here. I'm typing it in and then I'm going to explain, right? In this interval right here, the y's are greater than 0. We're not including negative 4 because on negative 4, the y is 0. And we are interested in where the y is greater than 0. And notice it's not greater than or equal to, so it's not including the 0, all right? So that is the area where the interval where the y's are greater than 0. Let's check our answer. No, we don't want to go to the next question. So in this example, we first found our vertex, then we found our our axis of symmetry. We determined that it's concave up. We found our x-intercept, our y-intercept. We graph our parabola. We found the domain and range, increasing, decreasing, and increasing, not increasing or decreasing, but where the y's are positive versus where the y's are negatives. All right. Hopefully I clicked so you can hear my voice.